We are going to be looking at problem 2.3.4. This is Chapter 2, Section 3, problem number 4. We are asked to solve the following system of equations by graphing. We have the system containing the equations 2x minus 4y equals 6 and 3x plus 5y equals 20. If we are going to utilize the graphing calculator to do this, the first thing we're going to need to do is to take each of the two equations and rewrite them into the slope-intercept form. They are now in the standard or the general form, and we need to get them into the slope-intercept form. Setting up my pen here, and we'll use blue. Now, if we look at the first equation that we have here, on this first equation we want to rewrite this so that we have it in the slope-intercept form. So the first thing I'm going to do with this equation is I will rewrite it as negative 4y is equal to a negative 2x plus 6. This gets our x term on the right side, and it gets the y term by itself. To finish this off into the slope-intercept form, we need to divide each of the terms by the negative 4 to get y by itself. And so doing that is going to look something like the following. And so we end up with the equation y is equal to, this would just be positive 1/2 x, and this would be minus, reducing that would be 3/2. So this is the equivalent equation for the first one, then the slope-intercept form, which is what we need to put it into the calculator. Looking at the second equation, we're going to do something similar. We're going to take this equation, and again we want to isolate the y, so I'm going to subtract 3x from both sides. This gives us 5y is equal to 3x plus 20. Now we're going to divide each of the terms here by the 5 to get y by itself. So dividing each term by 5, we end up with the equation y is equal to a negative 3/5 x plus 4. Now we're ready to go to the calculator. So I'll take the calculator here and turn it on. And what we want to do is to take both of these equations and put them into the calculator so that we can graph both equations. The first equation we have is 1/2 x, so I'm going to have 1 divided by 2 times the x, and then minus 3 divided by 2. So this is the first equation. Make sure I have it in there correctly. Now moving down, the second equation, we have negative 3/5, so this is negative 3/5 x, and then this will be plus 4. And these are the two equations. Before I graph this, let's look at the window that I have. The window that I like to use is this one right here. I like it for two reasons. One is it's a good size. Another reason is because this is a square window in that the ratio of the x range to the y range is 3:2, and so then everything is proportional on the screen. And yet a third reason is that these numbers here will give me nice numbers when I move the cursor around on the graphing screen. I'm now ready to graph these two lines, and so now if I hit graph, we see the two lines graphed, and I also have the grid on, in case you're wondering how to do that. If you go to Second, Format, you see that I have grid on here, and you can do that if you want. Back to the graph. Now this one here turns out kind of nice in that if we look at where it is, we can count the x coordinates as 1, 2, 3, 4, 5 over, and its y coordinate is 1. So it appears that the solution to this one is going to be the ordered pair 5, and I turned it off, there's back on, 5, 1. And my penmanship got kind of sloppy there, but you should be able to see that. In case you've never seen it, there is a way that we can also get this by doing the calc menu. So on the calculator, if I do second calc, And if I move down to number 5 here, intersect, what we can do is, first of all, there could be more than 2 equations graphed, so we have to tell the calculator which ones we're using. So this is the first curve, and that's going to be okay. The second curve is okay. Generally speaking, we like to move the cursor over till we get close to the point, hit enter, and once again we see the ordered pair 5, 1. This completes this particular exercise, problem number 4 in section 3 of chapter 2.